So this factoring section, we have two parts to it, really. We have this Roman numeral 1, we have Roman numeral 2. Roman numeral 1, honestly, a lot of people just kind of do it brute force like we were doing in section 4. But if you can see the pattern to it, it can make some of them a lot easier. So a while ago, we did ones like this. We did a plus b quantity squared. And the key is, and I wouldn't write this down, but the way that people messed up on the last test is they didn't remember that you have to do a plus b times a plus b and then FOIL. They just looked at it as, oh, it's a squared plus b squared, but that is not correct. When you do this thing here, and when you FOIL it, you do that times that, and that times that, this times this and that, you end up getting, let me erase all that, you get a squared plus 2, nice, plus 2ab plus b squared. So people remember that from last chapter? And that's part of the reason I taught it in the last chapter was for this section right now. Oops, I messed up. This next one should be a minus b quantity squared. I would write down the red stuff. Yep, I'd write down the red. The only difference in this bottom one is what compared to the top?
Subtraction.
Yep, it's subtraction. Where this one here on top is like a plus 2ab. The one underneath is going to be identical, but it'll be minus 2ab. So a squared minus 2ab. Still plus b squared. Because they'll do a negative b times a negative b, and those two negatives will kind of cancel and make it positive. We okay for that? The new part, though, in our last chapter, we started over here and said, hey, look, you could take this shortcut to here, and I'm guessing most of us didn't do that. What we're doing in this section is saying, well, if we have something like this, a perfect square trinomial, 3 parts, that's going to fit a perfect square, you could take and use one of these two properties to kind of work backwards. Fair enough? The way that you do it is this. If we were to take this and write it as a minus b times a minus b and then FOIL, do you agree when we did, let me find a better color. You just go for orange. Ooh, orange is kind of ugly. Let's go for brown. When we FOIL it, the f gives me the a squared. Agreed? And the L gives me the b squared. Well, if I want to find a and b, do you agree I could square root a squared? And that will tell me what a is. It'll tell me what this right there is. And if I would square root the b squared, square root this thing at the end, that would tell me what b is. That would tell me what goes right there. Yes? So if you want to check and see if these problems I gave you down here are perfect square trinomials, you could square root that to find b. You could square root this to find a. And then once you know a and b, the question is, does that give you this thing here in the middle when you put in the a and the b? So that's kind of how you check. So we'll work through one of these quick a second. So let's say I want to find a. Do you agree a is going to be square root of that? So a is just going to be x, right? If I want to find b, I square root the 36. So b has to be 6. Now, because this is plus 12x, do you agree we're talking about this top one here, this thing there? But the question is, does what come after that plus, does that fit this 2ab? So let me get rid of some of my writing there. Well, 2 times a is x, times b is 6. Do you agree that just gives me a 12x? Which fits my 12x right there, agreed? In other words, this original problem, which unfortunately I can't erase all of it because I hit the wrong button, but that original problem fits one of these perfect square trinomials, so my answer has to be that right there, the a plus b quantity squared. So we know a is x plus b, which is 6 quantity squared. Now, honestly, for these, I sometimes think it's easier just to go back and do what we were doing in the last couple sections. You have a trinomial, make 2 binomials, and then try to figure out which one it is.
Well, we could do that.
You could do this. And for some people, they'll latch onto this and they'll do this a ton. Other people are like, no, just let me rock it old school kind of thing. But all right, let's try this one here. Do you agree? This will be that bottom one. This, you have it on the same page, so I wouldn't rewrite it. But we're saying that that's going to fit this one here. So let's check and see if it does. So if I would square root this, that's going to give me a, agreed? So a is going to be 3x. If I square root this, that gives me b. b is going to be 8. So now we want to check and see, does the 2ab fit this 48x? Well, 2 times 3x times 8. 2 times 3 times 8. 6 times 8 is 48. It fits, right? So what we just found is we just found our original problem. We just found this thing here fits this thing here. So then we know the answer has to be a minus b quantity squared. And a is 3x, and b is 8. So we have our answer. Jump down to, I think, one last one. This still fits that same a minus b squared. I didn't go back to that top one. So a has to be 5x. Because we square root the 25, square root the x squared, we get a 5x. B is going to be 1. So now does 2 times a times b, does that equal this 8x? So 2 times 5x times 1 gives me 10x, right? So does it fit this? Nope, it doesn't fit that because our 10x, this here would be a 10x, doesn't match my 8x there. So then if you check that, you'd have to say, well, that didn't work, and go back to what we were doing in the last section, all right? It's a trinomial, so now I need to try to figure out what it's going to be that way. Fair enough? And I'm not going to actually go through and do that. I'm not going to factor it because we did that in the last section. So, but you'd have to go back to the old way. Old way. Dot, dot, dot. So Roman numeral 1, if you get it, great. That can save you some time. If you hate it and you can do section 4, just do it the old way. And that'll be totally fine. This next part's new. This next part I think you're going to like. This next part you'll probably use. So difference of squares. Works on binomials. A binomial is a polynomial that has how many terms? 2. 2 parts, 2 clumps. But it has to have, so with, maybe I'll write it out, with a minus in the middle. And here's what we're doing. I'm going to write it in red for dramatic emphasis. If I were to have a minus b in parentheses times a plus b, and we were to factor that, or I'm sorry, we were to FOIL that thing, we would end up with a squared minus b squared. And I'm going to kind of show why. I don't know if you want to mess up your notes, but when we FOIL it, I do that times that gives me an a squared, agreed? And then I do this times this gives me a plus ab. Then when I do my inside, I get a minus ab. And when I do my last, I get a minus b squared. So whenever we FOIL, we combine those two, but in this case, they just they wipe each other out. So we end up with a squared minus b squared. We end up with that right there. Fair enough? Okay, so let me try to get rid of some of this extra stuff at least. So in other words, if you start out with, I was afraid of that. If you start out with this a squared minus b squared, you can know then that it could be factored down to a plus b and a minus b. All right, so I have something squared minus something squared. So it's going to fit that a plus b. Most people won't write this step. I just don't want to lose anybody. But a has to be what? Square root of x squared is x. B is this thing over here because we're saying it's a squared minus b squared. So if b squared is 36, I could find b by square root on both sides. B is 6. So I know a and I know b. So I get a x plus 6, x minus 6. So this here looks like a squared minus b squared, right? Because what squared gives me 16x squared? You agree 4x Square the 4, you get the 16. Square the x, you get the x squared. And b up could be 12. So then if that fits that a plus b and a minus b, so a plus b, a minus b, we know it's 4x plus 12 and 4x minus 12. Isn't that slick? So the very last thing, this one here, is it going to fit? Because B could be a nice pretty 10, right? But A is going to be square root of x squared is x, but square root of 7 is... Let's just not go there. So this here, I wouldn't factor it this way because 7, square rooting 7 just gives you something ugly. So I wouldn't do it this way. So you're stuck going back to, can you pull out a greatest common factor? But we'll mess with that in the next section. So that's it.